Hello everyone. So I had missed a day on this, or a couple days. I've been busy this weekend, but this maximum frequency stack, I skimmed through some of these problems, and divide integer is pretty easy. It's an easy problem. I've already done it. Validate the stack. This is a very interesting problem. Tried my hands out on it. It was a little difficult. So basically this problem is like you're given two sets of pushed and pops, and then you're supposed to figure out whether it's possible to do that from a regular stack. So you're supposed to trace the push and pop of the stack to see if it's even possible to have this type of sequence for push and this for pop. So I thought that was a really cool problem. But I've already done it. And so now I decided to see if I can do this one. This is the next cool problem that I didn't do this weekend. But yeah, I think this is a very cool problem. I think it's probably a hard problem because the our boundaries are pretty high, so yeah, it's going to be interesting to figure out an efficient solution. But I already have one in mind. I've already read through this. So the idea here is that it's a stack, but it's a modified stack. It's a frequency stack. So you push and pop like a normal stack. Problem is, when you pop, instead of popping the top, you pop the most often one. And then there's an extra complexity also, that if there are two max frequency ones, then you want to take out the ones closer to the top. So yeah, so that makes the problem extremely complex, in a sense that that would be easy if it's like you have infinite time, but because you have a lot of calls, this would be very hard. So my initial thought is, brute force approach is when you push, you sort every time, and then you keep track of the max frequency, right? And then so when you pop the ones at the first, but you sort every time. That's n log n already times this n, so that's not gonna pass because that's too slow. So the next idea is then a priority queue, where it's basically a heap which keeps track of the maximum at the top. The issue is that it's hard to know in a heap which when there is a case of two max frequencies. How would we figure out which of the two to pick? Because in a heap, you normally just take the maximum frequency, and the maximum frequency in the case of two max frequencies is either one. So this heap would just pick either one. But let's start with that and see if we can get an idea on how to progress from there. Self dot record, self dot stack, but not really a stack. I'm just calling it a stack. It's technically a priority queue. I think it's from queue import priority queue. Let's see if that fails first. Make sure that I have the priority queue right. So that compiles. And then the next step is every time I push, I keep track of the I push it in the priority queue based on the weight of its frequency. So I count the frequency like this. So if x in self.record, it's already there, then I want to say self.record x, you increment that by 1. Otherwise, self.record gets an initial value of 1. Okay. Now in the self.stack, what I want to do is I want to do a priority queue. The weight is the record. So self.record x. Priority queues normally are minimum at the top, so in order to reverse that, just multiply by -1. And then the next is to store the item, of course. Okay, let's see what we can do with that. Or yeah, so this is the weight, this is the value. Self.stack.get return v. It's not callable. Oh, stack.put. Already on the first problem, we have an inability to distinguish when, in the case where there's 2 max, you pick which one. But at this point, there is going to be, from here to here, there is 2 5s and 2 7s. But my program is choosing the 5 when it should be choosing 7 because it's closer to the top. Even though they have equal frequencies. So I believe this is a comparator put, or this is a comparator of weights. So if I put in another item there, would it compare the second item if it's equal? Let's see. So if the index equals 0, actually I want to do it after I put it in the queue. Reverse that. I just realized that I need to match the I need index there, but I'm not going to use the index. Oh, that's interesting. So I found out something about the priority queue. It's a comparator of the weights in the front. So, or actually it's a comparator of all the tuples. So because that makes sense. 5 was going first earlier because it is less than 7. So it's gonna, oh, I see. So having this would actually put the weights of the queue based on the comparators. This makes sense. Okay, well, let's see. One. What's happening there? let's see. So push, 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 pop. That's pops one. Pop again. That pops one again. Push, push, push. Oh, um, one is at the top at this pop. So why is two? That should be right though. Why is two at the top at this point? One should be at the top. So it should be the next thing that's pop. Oh, this is messing with the weights. So the pop messes with the weight. So in those two pops, I need to record V, subtract the weights. That works. Yep. So yeah, so this is a very difficult problem if you are not super versed with priority queues. I struggled with it because I didn't really know how to get the priority queues, but if once you have that, it should be pretty easy. I'm assuming it's pretty slow still, because one thing that we could also do is that the priority queue doesn't discriminate what's still a item in the queue that will get reached, right? Because now you're just flooding the memory, but it seems to not care. But in like software, I would make sure that the priority queue is only the same amount as the number of records, the sum of all the records. That way I don't flood the priority queue with things that are never going to get reached. So yeah, so that's it for today. Next time.